The GWT Technology Services Center, where I work, is responsible for deploying and managing the LANs, the MANs, the WANs within our territory that connect all of our government offices. It also includes health and education facilities. The digital network provides data services for about 5,000 plus government employees and another 5,000 users in education facilities, and extends to all 33 communities across the vast north, many of which are only accessible by plane. We only have 10 staff to look after the entire network, which keeps us busy, especially when staff have to travel to the other 32 communities to install and or fix equipment. Due to the large and geographical remote area, it's complex and expensive to deliver IT services. As you can see by the slide, the city of Milwaukee has about 6,000 people in about a 10 square miles. Where in the Northwest Territories, we only have one person in that same 10 square miles. Due to the remote northern area, delivering a digital network for the government and education is very expensive. The GWT Technology Service Center, we have an annual budget of about $26 million to provide IT services, and almost half of that is used just to provide the digital network. Right now we have fabric that exists in our data centers, government buildings, schools, health offices, and our main hospital. Physical connectivity to all the sites is a combination of fiber optics, copper, microwave services from the main provider in the territory. And our fabric network, as Camille said, was first deployed in 2013. Very happy to be the first in Canada to hold that mark. It was a little bit of a contention a few years ago when we talked about that, but I'm glad to hold that, that we can maintain that. Right now, we span about 500 to 600 buildings, many of which include very small offices of 10 plus people. The schools and the government networks are completely isolated on their own virtualized network running across a common fiber backbone. We've deployed approximately 300 fabric attached enabled APs, and segmentation within the data center is done so we can separate and firewall between each of our application tiers. We have always been an early adopter of new technologies, trying to keep up with the latest and greatest. We're continuously evaluating new technologies to see how they might fit into our environment. At the time, we started looking at fabric, and there's a lot of emphasis at the time of software-defined technologies. And right away, I could see that capability exists within fabric. When I described, how it works to the staff, it took some time to grasp because they're like, really? That's all you have to do? Normally in most environments, when you simplify, you lose capabilities. But with Fabric Connect, it simplifies the network while providing better capabilities. We just define services at the edge, and the core takes care of itself. Here's a perfect analogy. Before using Extreme Fabric Connect, it was complex and time-consuming to add new devices. So it would be like going to the store. You go buy a new toaster, but before you can plug it into the kitchen, you had to call the power company. You'd say, well, what kind of bread are you going to be using? Well, I'm going to be putting regular toast in that. Why? Well, we need to know so we can configure that circuit properly. And where are you going to plug that in? And don't even bother saying, well, maybe I want to move that to another room in the house. It really sounds silly, right? But that's the way we used to do things before Fabric. Now with the Fabric, it makes it almost as easy as using a toaster in your house. The Fabric network, we're able to create device profiles that dynamically configure the network based on the location where the device is connected. So when a device is connected or it moves to another location, that dynamic configuration is removed and it doesn't leave a security hole where something else is connected. So all the controls are at the edge. If you want, you can even burn bagels in your bedroom if you want. So our benefit, we don't have to spend a whole lot of time troubleshooting the network because all the different layers and the protocols have been removed. When the switches are Fabric Connect enabled, they automatically learn about the network, so then we can just start deploying new services. Now we go right to the edge and troubleshoot from there, and we can make modifications to the network on the fly. So we currently are in the process of upgrading our VSP 9000s, which started our fabric journey many years ago. Since all the ports in the core are fabric NNI, there's no spanning tree. We just have to connect new VSPs and they automatically add themselves to a loop-free multi-path environment. Previously, when we upgraded components in the core, we had long outages due to the complex configurations. Now we're able to upgrade all the core network devices in staged upgrades with minimal or no network disruption. If you're new to Fabric, well, we've been using Fabric for a long time. Both David and I, we can probably test that we feel like we know it in and out, and we've come up with some shortcuts or different things. So we have a fairly good methodology and a plan how we put every single node into the network. But now, I think with some of the work that's been going on, there's a lot of new scripts that can be used to configure the switches. And even with the zero-touch Fabric onboarding, it's going to make things a lot easier. So, when you get a new Fabric switch, just say, here, yeah, let's configure it up and start using it. Don't be scared to use it. In order to manage that vast network, we decided we needed to deploy Extreme Management Center for centralized management. If somebody calls into our service desk and they complain about slow response time for a particular application, previously we'd have to go in and we'd trace through that hop by hop, every single device along the way, just to figure out where the person is and what they're connected to and what problems may be along the way. Now with XMC, we can see the user because it's integrated into our Active Directory, and it tells us exactly where they're located, what switch they're located on, how their network is configured, and what type of device they're logging in with. We get a single pane with all the information rolled up into one view. With network access control, we have the ability to do dynamic port configuration. We're able to deploy generic configuration for switches so that all the services, the VLANs and ISIDs are dynamically provisioned as users and devices connect to the network. The switches also have analytics built right into them, so the application telemetry allows us to see the application response times for various applications. So one use that we looked at was due to the impact of COVID, as many people ran into, we experienced a sudden growth of remote workers and collaboration apps. So using data analytics, we're able to report on how much traffic was used for collaboration, for example, like Microsoft Teams. We were able to determine that Teams consumed 25% of the available bandwidth we had, which really helps us justify that we need more bandwidth to accommodate and build on those applications. So we installed a brand new hospital, and with that new hospital had 200 access points. It had, I want to say, a couple of thousand network drops. We decided to do full Fabric Connect network with network access control. Since the hospital is a very complex environment, there's a requirement to section off medical devices such as patient monitoring, infusion pumps without, from the rest of the network. It would have been very tricky to install without network access control. Going to each individual port and saying, oh, this is the VLAN I want for this one, and you couldn't move things. But we were able to deploy generic configurations on the switches and then let access control determine and provision all the segmented VLANs. For patient monitoring, we were very leery because it used multicast, and we had never used multicast before. It was very cool to see it being introduced into the Fabric. All the ISIDs were dynamically created across the backbone to support the multicast traffic, and we didn't have to configure anything in the core. I was like, well, why are we worrying about this? It's really simple. In our case, the old and our new hospital were right beside each other. So we were able to do a live migration in one day from the old network to the new one. They just started moving the patients over, wheeling them over in their beds from one hospital to the next. Patient care wasn't impacted. So we use wireless access for employees and the public within the hospital. And we're also working with the museum to deploy access points there. We're starting to deploy Wi-Fi 6 technology with our new access points. And this summer, we're planning on installing VSPs in all of our remote communities They'll all be Fabric enabled by using Fabric Extend to connect across a private WAN. We use analytics to see the best way to utilize that bandwidth in each of these locations, because bandwidth is very expensive up here. We can create a fully virtualized network over the WAN with segmentation to control traffic between government offices, education facilities, and voice services. And looking towards the future, we're looking at location services with BLE, things like being able to move to a network and application analytics to a people-centric analytics. Maybe see how many people are repeat customers at a museum, things like that. We're kind of looking at potential use cases there. Even moving to the cloud. Being so remote, we've been very, let's call it cautious optimism. Every organization really has different challenges and requirements with the cloud. And there really been some exciting capabilities available with the new features being added at cloud speed almost daily. So really, we're looking forward to using Extreme Cloud IQ in a flexible deployment that really works the best for our organization. Thanks.